Hi guys, I'm Yutaka Takaguchi. I will discuss about the thermodynamics of the chemical reactions in this course. First of all, I would like to provide you the introduction part of this course. Here you can see the note of mine, the chapter 1, introduction. Okay. The first I would like to talk the chemistry looks like cooking. Maybe some of you are doing cooking every day, and that, you know, is very similar to the chemical reaction performed by the flask and, heating unit. The compounds A put into the flask with the solvent and add heating. We observe the transformation of the compound A to compound B. And importantly, this compound B does not transform to the original compound A by cooling. This is very important. That's why we can obtain compound B as the important chemical material, such as drugs or, some important, part of the pencil or something. And the question could be, in your mind, why do we need to apply the heating to obtain the B? And why does not the retro reaction occur? We don't obtain the A from the B. So this chemical reaction is actually irreversible process. This is very important. In order to discuss about these kind of things, we need to think about the relation between chemical reaction and energy. This is chemical reaction, and heating is actually the energy, okay? This is one of the typical chemical reaction. Neutralization. Maybe all of you have some experience to do the neutralization, such as, HCl, hydrochloric acid, and NaOH, sodium hydroxide. HCl is acid, okay? NaOH is base. So this is a typical acid-base neutralization reactions. Provides the H2O and NaCl and heat. Neutralization makes actually heat. This is energy. So where is this energy coming from? This is a big problem of the chemical reaction. If you can understand this part, you can understand the chemical energy. And that is very important part of our lives because we've got the chemical energy by the photosynthesis of the plants. We eat them, or cow eats them, or pig eats them, and we eat such kind of chemical energy from the solar power. Okay, so this kind of discussion, I mean the chemical energy transformed to the heat, is very fundamental question of the chemistry. So this is one of the understanding chart for the heat by the acid-base reaction. The y-axis is the stability of the chemicals. Okay? The acid and the base is unstable form of the compound. After neutralization, we've got the salt, NaCl, and water, H2O. These materials are stable form of the compound. So from these difference, we can obtain the energy as heat. So this is actually the chemical reaction, but in other words, this reaction is energetic transformation. Then we can get the heat. To understand this correctly, we need to understand the thermodynamics of the chemical reaction. Thermal means the temperature and heat, okay? And dynamics means the mood or behavior. So if we can understand the temperature movement or temperature behavior or heat movement or heat behavior of the chemical reaction, we can completely understand this kind of speculation of the chemical reaction. And here you can see the important issue of the thermodynamics is where does energy coming from? Where does that energy go to? This is very important. And this idea is actually coming from the energy important issue of the energy conservation. Energy conservation law. Okay. So if you can imagine the billiard shown here, the white ball hits the black ball. This is the hitting point, and after that, white ball stop here, but the black ball go to the same energy with the white ball. This is the one of the typical situation of the energy transformation. Kinetic energy of white ball transfer to the kinetic energy of black ball. This is very easy process. Another type of the transformation of the energy is light bulb. This is the light bulb. First, the electrostatic potential applied to the light bulb. This potential energy changes to the kinetic energy of the electrons. Electrons go to this light bulb with the kinetic energy of the electron, and that kinetic energy transforms to the light and heat on this filament. So this is important for the energy conservation law. This is the potential energy transformed to the kinetic energy, and the kinetic energy transformed to the light energy and heat energy. The structure, the expression of the energy is different, but the total energy is always the same, okay? And as I described before, the photosynthesis is one of the very important issue of the energy conservation law. Solar light transforms to the carbohydrates from carbon dioxide and water in these leaves, okay? And carbohydrates is actually chemical energy getting from the solar light made by the chemical reactions. and we eat these carbohydrates. This is very important for us, okay? So chemical reaction can also be explained by thermodynamics. This is our first standing point of this course. And to understand this kind of thing, we need to, understand the first law of thermodynamics, so-called energy conservation law. Energy cannot be created or destroyed. It can be transformed from one form to another. Okay? After understanding this first law of thermodynamics, we will go to the how can I understand the energy of the system for the chemical reactions. Okay, so next video I'll provide the internal energy of the system.